In this lesson, we are going to talk about the refraction section of the V-Ray material. We have the same scene that we used in our previous lesson, but instead of the shader ball, I have this vase and bottle and also this diamond, which is hidden right now, and we'll be using it later on. So let's open up our material editor and drag a V-Ray material into the active view. Most of the refractive and transparent materials have a very dark diffuse color. So let's set a very dark color with the value of 2 for our diffuse color. Also, if you take a look at a piece of glass, you would notice very strong reflections. So let's use a reflection color with a value of 200 maybe, and set the reflection glassiness to something like 0.95. Now we are ready to start working on the refraction section. First, we have refraction color, which controls the color and the amount of the refraction. When set to black, we are not going to get any refraction, and when set to brighter values, we start to get refraction and transparency qualities. Let's select our bottle and vase and assign the material. Run the active shade and see what we get. As I'm using brighter values, you can see we start to introduce refractive qualities to our material. We can use any other color to get a colored glass if we wanted, even though there is a better way to get colored glass using the fog parameters down here. But we can use green, blue, or any other color that we want here as well, even though it's not going to be as realistic as using the fog color down here. In this case, let's use something like 245 so we can have a clean glass. We can control the refract or refraction color with a map. So let's click on the refraction map and let's use a gradient ramp. Let me rotate the map by 90 degrees on W. Change the black color maybe to a green color, and let's change the medium gray to white. And there you have it. We are controlling the refraction color with a map. Now let me delete the map for now. Next we have refraction glassiness, which controls how sharp or blurry the refractions are going to be. At 1 we get sharp refractions, and as I decrease the number we get more and more blurry refractions. One important point when dealing with blurry refractions is the fact that you need to also make the reflections blurry, or you would get very odd results, because you would have sharp reflections on top of blurry refractions. So let's decrease the reflection glassiness to 0.8 as well, and make sure the refraction glassiness is also 0.8, and see what we get in the active shade. Now let me stop the active shade and show you a few renders with different refraction glassiness values. In the first render, both the reflection and refraction glassiness were set to 0.97. As you can see, we have a very clear reflection and refraction. In the second render, glassiness was set to 0.85. Now we get that blurry look. And in the third render, it was set to 0.7, and as you can see, it's much blurrier. I used progressive image sampler for all the renders here, and I rendered them for 3 minutes each. That's why the third is more noisy. As we decrease the glossiness value, we need to spend more rendering time in order to get noise-free renders. Like other parameters, we can control refraction glossiness with a map. In this case, let's load floral01.png. This map is pure black and pure white. There is no in-between gray values. So where it's white, we get glossiness of 1, and where it's black, the glossiness would be 0. I don't want that, so let's select the map and go to its output rollout. Enable color map, and let's make the dark values a bit brighter. Maybe something like 0.65 would be enough. And if I render the scene with the current settings, as you can see, now we have this floral pattern controlling our refraction glossiness. Let me clear out the map and set the reflection and refraction glossiness to 0.97. Run the active shade again. Next we have IOR, or index of refraction, which controls how much light is bent or refracted when entering a material. For a vacuum, this number is 1, so the light won't bend in vacuum. That means basically the speed of light is not going to change in vacuum. For water, the number is 1.333. And that means light travels 1.333 times faster in vacuum compared to water. For most household glasses, it's something like 1.5. For diamond, it's something like 2.5, and you can find out the index of refraction for different transparent materials on web. Simply search for them, and if you are trying to create a specific transparent material, enter that IR number here. And you can visually see the changes in the refraction in the active shade as I'm changing the IR value here. Let's set it back to 1.6 and stop the active shade for the time being. Next we have app number, which allows us to enable dispersion effect for the V-Ray material. And the app number value here controls how strong the dispersion effect is. As you decrease the number, the dispersion effect becomes more obvious. Now let me hide the bottle and the vase and unhide this diamond and show you 3 renders, or 4 renders I think, with different app number states. Let me first select the diamond and apply our material to it. In the first render, app number was disabled and we get our regular no dispersion render. In the second render, app number was enabled and set to 50, and we start to get dispersion in our render, but it's not that obvious. In the next render, it was set to 10, and now the dispersion effect is wider and more obvious. And in the final one, it was set to 2, and as you can see, as we decrease the app number, the dispersion effect becomes stronger. Let's set the app number to its default of 50 and disable it. Also hide the diamond and unhide the bottle and the vase again. Next we have effect channels, which works exactly like the effect channel parameter in the reflection section, and it specifies which channel will be affected by the refraction portion of the material. If set to color only, refraction affects only the RGB channel of the material. If set to color plus alpha, it will affect both RGB and alpha channels. And if set to all channels, it will affect all the eligible render elements. Now let's set it back to color only. Next we have subdivs, which controls the quality of glossy or blurry refractions, and it's grayed out because use local subdivs parameter is disabled in the global DMC settings. But if use local subdivs was enabled, increasing subdivs value here will result in cleaner glossy refractions and increased render time. Then we have max depth, which is the number of times array can be refracted, and exceed color that will return if array has reached the which is the color that will be returned if array has reached the max depth or maximum refraction depth number. Let's set the exceed color to a bright red color, maybe a red to 255, green to 2, and blue to 14. And let me show you a few renders with different max depth numbers. In the first render, max depth was set to 1, and all we can see is the exceed color. In the second render, max depth was set to 2. In the next one, max depth was set to 3. Then we have max depth of 5, and we still need to allow our refraction rates to be refracted more as we still see the exceed color. And in the final one, max depth was set to 9, and now we have a clear render. In most cases, if exceed color is set to black, you really don't need to increase the max depth number more than 5, but if there were lots of refractive surfaces in your render, you are gonna need to increase the max depth number, which is gonna increase the render time in turn. Let's set the max depth number to 5 and exceed color to black, and also let's disable exceed color. Finally, we have effect shadows, and when enabled, it will give us these transparent shadows, and if disabled, we are gonna get opaque shadows. Let me just run the active shade. As you can see now, we have these transparent shadows, and if I disable it, we get these opaque shadows, which is very unrealistic. Let me stop the active shade and make sure effect shadow is enabled. Next, we have fog parameters, fog color, fog multiplier, and fog bias. And using these parameters, you can make realistic color glasses. When you use fog color to make colored glasses, it takes into consideration the fact that thick objects are less transparent compared to thin objects. Now let's change the fog color to a green color, for example. Maybe set the red to 186, green to 245, and blue to 129. And as you can see, now we have green glass, but in the thinner parts of the object, we have a less saturated version of that green color. And in the thicker parts, we are getting more saturated, more kind of darker version of that green color. So the color changes based on the thick and thin parts of the object. Fog multiplier multiplies the fog effect, and as you increase it, you can see the fog color is more saturated, which makes the object to look less transparent. And if I decrease the multiplier, the fog color becomes less saturated and the object look more transparent. Finally, we have fog bias, which basically controls the contrast between thin and thick parts of the object. If I increase the value, the fog color becomes more even in the thin and thick parts. And if I decrease it to a negative value, the contrast between thin and thick parts becomes more obvious. So the thin parts are going to use less saturated color and become more transparent, and thick parts are going to be using more saturated and darker version of the fog color and become more opaque. Okay, so in this lesson we learned about refraction section of the Vray material. In the next lesson we'll be discussing translucency and possibly self-illumination. See you there.